on our own time. So if you would like to volunteer for Bangpypers, most welcome to do so that. And if you would like to speak at a Bangpypers event, we have a CFP form that we regularly post, and the link is actually the same every month. So you can also submit your talk proposals there, and we will reach out to you and invite you to speak here. Speaking of which, we are also involved in a conference called PyCon India. Can I see a show of hand of how many people know about PyCon India? Okay, how many people don't know about PyCon India? Raise your hand if you don't know about PyCon India. If you have never heard about it, you don't know what it is. Okay, few people, not many, but few people. So PyCon India is the Python conference of India. This started around 2008, 2009, I think the first time. And now, since last year, PyCon India 2020 was online, this year will also be online. So this is an annual conference, happens once a year only. You will get really good speakers from India and outside there. You'll have to interact with other communities as well, other companies, and so on. So it's a really good space for you to join and see what other folks are doing. There are workshops involved, there are dev sprints involved, and so on. Similarly, Bangpypers also has a lot of various types of events. Today's is a talk event in which a speaker will be presenting what they have been working on, and you can ask questions to them about what they are about if you think it's related to your field, if it excites you, and so on. We also have workshops. We also have webinars, one of fireside chat sessions, dev sprints also. However, dev sprints since last year been online. We are still figuring out how to exactly conduct dev sprint in a best possible way. If you have ideas, feel free to share with us, and share with everybody here. We would love to know your thoughts and views on that. So we'll get started today. We have 3 talks today. Anshul, Rakshit, and Shashidhar sir. We'll have a small break after the second talk. And then towards the end, we have an open house session. What happens in open house session is essentially it's an open discussion forum where we talk about anything and everything, hopefully around Python and other projects and what people are working on. So without further ado, Anshul is the first speaker. He will be talking about understanding concurrency in Python. Anshul, over to you.
Cool. Thanks. So I'll share my screen.
Yeah.
So I think screen share is disabled. Can you enable it for me?
Okay. Hang on a second. Yeah, try now.
Yeah, I can see my screen. Okay. Can you guys see my screen?
Yes, we can.
Okay, amazing. So hi guys, I'm Anshul. So I'll give a formal introduction as well. So today we are going to be talking about concurrency, and so this is the agenda for today. We'll be talking about what is concurrency. We'll talk about threading and async IO, and we'll also try to understand when concurrency is useful. We will take 2 types of tasks, and we will see how the different paradigms or different features of Python programming language do in these kind of programs, and then we will conclude. Apart from this, I think I want to do some expectation setting before we get into the talk. So we're going to be learning about concurrency. We will be also learning about the features available in Python that support concurrency. When to use which feature to use basically to speed up the execution. We will not go into a lot of detail about these features. There are going to be documentation that you can go back later when at your own time and go into details of these features. But we will do some demos as well, and we'll try to understand when to use which features. So let's start. I see that there are a bunch of things in the chat. Okay.
So if some question comes up, I'll say it out loud. So
Yeah, first set of introductions. So I'm Anshul. I'm a product engineer at Udan. I also coach early software engineers at Scalar Academy. So I'm a career coach there. Previously I worked at Springboard, which is an education tech company. I worked at Amazon and Jabong, which were e-commerce companies. The technology stack that I'm familiar with is Python Django. I worked with Python Django for almost 5 years. I worked with Java for almost 2 years. Currently, I work in Kotlin. I am learning Kotlin and cooperative multitasking. These are my social media handles. You can reach out to me after the talk if you have any questions as well there. So let's start. Okay. So what is concurrency? Concurrency definition is, is something like simultaneous occurrence. In Python, the things that are occurring simultaneously are called by different names, right? Thread, task, or process, right? So if we want to execute something simultaneously, this is concurrency, right? Each one can be stopped. So these different names that we have said, right? Thread, task, and processes, these can be stopped at certain point, and the CPU that is processing them can switch between one another, right? And operating system basically does that for you. In certain cases, it is the responsibility of the process itself to basically switch out or context switch on its own, right? In a sense, only multi-processing is basically does that works simultaneously. I don't know if all of you are familiar with GIL in Python. That basically uh, allows you to basically have one process running at one CPU at a time, right? So only multiprocessing is the paradigm or a feature where you have multiple processor and you can run multiple processes on these processes to have simultaneous work. Threading and async IO both run on single processor, but they just find clever ways to take turn to speed up the overall process. And let's talk about how threading and async IO is different then. So if we talk about the operating system actually knows. So we create a lot of threads. So now the operating system knows about each of these threads, and they can interrupt the thread at any point in time. This is called preemptive multitasking, where the operating system is interrupting your thread in between. It can interrupt the thread at any point in time, right? At any time, and then give the control back to the process or the thread at any point in time as well. And the thread should start from there itself. It does store some contextual variable, but I think that's how threading works. And preemptive multitasking is good because the thread itself does not need to know or plan for the switch on its own, right? Because operating system is taking care of that. If we talk about async IO, so in async IO, task must cooperate by announcing them when they are ready to be switched out. This is called cooperative multitasking. In this paradigm, basically the tasks pronounce or announce to everyone that I can give away control, right? And I'm ready to be context switched. And then there is a event loop which will basically take this process and put it on the waiting queue and give control to the other task that is there. We will talk about all these things in more detail as we go along, right? The other thing that is different, if we compare that with threading, is in async IO, the task or the code needs to know, when it's going to be switched out, right? And it has to announce it. So it means that you have to do some extra work, right? You have to plan for that, right? And but the thing is, when I've started to do async IO, right, or cooperative multitasking, what it does is it simplifies your design. It simplifies your software design, and we'll see how that happens. Let's move on to the next thing. Let's talk about when concurrency can be useful. So concurrency can be used in two types of problems. One is CPU bound. So these are classes of problem that have significant computation, taking into account the net without taking into without talking to network or accessing a file. So an example of this is if you want to calculate the value of pi, right? Or if you want to do some heavy mathematical calculation, right? So those kind of processes or those kind of programs come into this category, right? Over here, the limiting resource is your CPU speed, right, and not the network, right? So these kind of programs are basically very common in scientific research, right, where you have all the data available in your memory and you want to just crunch those things, or you are generating a lot of data and then processing it as well. It's not huge that you can't store it in your primary memory. Now, the second class of programs is IO bound task, which is so basically in IO bound, the program is slowed down because it has to wait for input output or some external resource. Input output could be network call, or it could be reading from a file, right? They arise frequently into the development, right? Because if you're coding a product for any company, right? So think about e-commerce, right? There will be a downstream dependency. You might be calling a mailing server, or you might be calling Google if you are using some of their services, right? So you have to wait for them. I think we've moved away from a place where we are reading and writing to the file. Some still do in some special situations, but network calls are still very common in any kind of products that are there. Products that people use these days. So we'll talk about the IO bound programs first, and we'll take a sample problem and we'll try to code across different features that are available to speed up the execution. Okay. So the sample problem that we have is that we want to download content over the network. For example, we'll be downloading certain web pages, and so it's really any network call, right? You can call an API, or in this case, we are downloading the web page, but you can call a an API or anything of that sort, right? So the first example is a synchronous version, and I'll give you a couple of minutes to folks to read through this code, and then we will, I'll talk about the silent features of this code. By the way, these codes are available at the end of the presentation. I'll be sharing the link to this presentation with the group, so they can go back to the GitHub repository and see these codes, and they can also run them on their own machine as well. So giving a couple of minutes for people to read through this. I'll give like a minute for people to read. Okay, I'll try to explain the code. When you run this script, what happens is there's a site list which has Amazon and Amazon.com and StackOverflow.com, and then you multiplied that by 80. So now you have 160 URLs. You're starting the a timer here, and then you are trying to download all these pages, and then at the end of it, you are still stopping the counter and trying to get the difference between the two, right? So that you can measure how much time this method took, right? Now this method is very simple. So we're using request module, and for the session we will be iterating through all the URLs in the sites list, and for each of these URLs, we're gonna be just reading, or trying to make a get to this URL, and we're just printing the response content का length हम print करें, and we'll also print the URL, and after that we will print the how much time did it took, right? And for 160 URL, it took almost 15.89 seconds. Not bad, right? So what are the good things about this code? Folks, I want this session to be interactive. So what are the good things about this piece of code? Anybody would like to contribute here?
You're using the same session object for all your requests.
Yeah. So one of the good things about this code is that this is easy. This is easy to understand, right? The other thing is that it's easy to debug. You will put a PDB somewhere, and you'll be fine, right? You'll be able to uh, debug it really quickly, right? Because you understand how this is happening. The other thing is that there's a single train of thought, right? There's one process that is running, and that's just one process, right? So single train of thought is there, right? So those are some of the good things about this code. Not so good things about this code is, or the problems, I would say, it's dead slow, right? It took almost 15 seconds for us to basically do these calls. Although being slower is not necessarily a big thing, right, or a bad thing, right? If your program runs very rarely, or if the completion time is within SLAs, right? So you can use synchronous versions to do these kind of work where that your program is not going to be run very frequently. And if the SLAs are such that you can be fine to actually, if your SLA is like 20 seconds, then it's fine, right? For it to run for 15 seconds, right? So you need to understand in the what kind of environment you are and then adapt. But if your program run frequently, right, we have daily tasks, right, on our plate, right? All our applications have daily tasks, right? So they run very frequently. We have hourly tasks as well, so they are going to run every hour, right? And if it takes hours to run, right, then we have to do something better than this. And that's where we will go into the threading world. So I'll go to the threading example now, and I'll try to explain what happens. So I'll give you another minute to basically read through the code. Actually, let's start to read through the code together. So if we start from the main function or main here, so we did the same thing. We basically created a list of 160 URLs. We started the time. We basically ended the time, and then we called a method called download all sites, and we passed this list to that site. Now, what we have done here, right? So what does download all site does? Now this function has changed, right? So what we are doing is we are creating something called a thread pool executor, right? So which seems like a complicated thing. So I'll break it down. Okay. So it is comprised of three words, right? Thread pool executor. So this object is going to create a pool of threads, each of which can run concurrently, right? And the executor is the part that is going to control how and when each of the thread pool will run, right? And so that's how. So that's thread pool executor. And with the executor, we are calling a map method. So map method basically take two arguments: a function that you want to apply on each of the item on the iterable, right? So this is an list. So for each element on the list, this executor will be calling download site, okay, when the executor has the threads available, okay. Uh, so the great part is that it automatically runs them concurrently using the pool of thread it's managing, right? And the other change that we have done, right, it's in the download site itself, right? So what we are doing here is, in our previous example, we were using request.sessions. However, we are, basically we've created another method, which is get session. And basically what we are trying to do is, we are, each of these threads are going to run in parallel, they will all create their session object, right? We don't want that. We want these threads to basically share, this thread or this session object, right? Because the operating system is in control when your task get interrupted and another task start. Any data that is shared between the threads need to be protected and need to be thread safe, right? And threading that local, right, basically provide you that abstraction so that you don't basically use each other's object across threads. What are the problems with this solution? So I wanted to ask, what are the challenges that you're going to see with this solution?
Yeah, so I was thinking the get session will be the critical section, right?
Yes.
The get session method will be the critical section, right? So it is possible that multiple instances of session will be created for different threads.
Yeah, and that is fine, right? That's what we want, right? But if for a particular thread, if the thread local we have set a session, then basically we don't want to create it again, right? We want to use the thread local session itself. Yeah, so one of the key challenges with this approach is that you need to basically do some work, obviously, because there is a critical section and you can have problems with that. So you have to plan for it because you don't know when your thread will be interrupted, right? Operating system is in control of that piece of information, right? The other challenge that we have is that I've put in maximum workers as 5, right? And how do you decide these maximum workers? So it requires some hit and trial, right? In my case, I got the best result if I kept the maximum workers as 5. But this is going to change. This is going to change if the number of URLs are going to change, right? This is going to change if the machine is going to change, right? So this number basically depends on a lot of factors that might not be in our control. And deciding this number statically is will not give you the best results, right? Right. The other thing is one of the other thing that you would say is that if there are 160 downloads that are happening, let's create 160 thread pools, right? But that might not give you the best result. Can anybody tell me why is that? Trashing context switching. Okay. So basically, when you create threads, creating thread has an overhead, right? Because you have to create operating system does a lot of work when you create a thread. So there's an overhead that is there. So the other competing factor is that you will get a speed up from concurrency because they are running in parallel, right? But there is an overhead as well. Now, these are the two competing forces that are working here. So you have to balance these forces. If you go to the other end where you create a lot of threads, the overhead of creating and destroying the thread will surpasses the speed up that you got due to concurrency, right? So that's why you have, it can't be equal to the number of number of operations that you want to do, right? And basically based on that you have to figure out, right? So on each machine, this is going to be different. On each operating system, this is going to be different, right? Because operating system will create and destroy thread differently, right? Also on machines, right? What is the kind of load that is there on the machine? And at different time as well, the number of threads that are already running, right? It will also depend on that as well, right? So there's a lot of variability in terms of what will be the optimal number of thread that you want to run, right? So let's talk about some of the good things about this version, right? So one of the key things that we can see here is that we still got the same number of URL gets. But the time for this is like 3.8 seconds, right? Which is much better than what we had in the previous example, which is like almost 16 seconds, right? Now we have done, this is very fast, right? But much faster than our synchronous version. So why is that? Can anybody tell me why is that happening?
Because we are using concurrency, so it's like trying to optimize the network request. So when one thread is making request, it is switching it, and then at the same time other processes start making the request.
Yes.
So it is kind of optimizing the thing.
Yeah. So the way to think about it is, so there is a wait in each of the thread that you're running, right? For each of the download side that you're doing, there is a wait when you're doing this get, right? So you're waiting for the network request. Now, what will happen is, what you're banking on is that when you are started to wait, right, operating system will interrupt your thread at that point in time, and it will, right, because it wants to give control to other thread as well, right? So there will be some overlap in the waiting time of various threads, right? And basically what it means is that while one of the thread is waiting, the other thread got the CPU and it is executing, right? So if, you have overlapped some of the waiting times, but because operating system does not know that you've made or you're waiting, right, it will arbitrarily preempt you, right? It will not preempt you as soon as you start waiting, right? So there is some overlap, but not the best solution out there. What are the not so good thing or problems with this threading version? Obviously, there is more code that we have written, and the other thing is that we need to really think about how to keep our code thread safe, right? The other thing is this example will be very difficult to slightly difficult to debug as well, because threads can interact in a very weird way, right? And it becomes really difficult to debug when uh, uh, threads are basically interacting with each other in a weird way, right? And even replicating issues become difficult, right? You will have intermittent bugs, right? Because threads are interacting with, there will be a special situation where this thread was doing something and your thread did something else, and it's super difficult to replicate those bugs.
We have a question. Sorry to interrupt. We have a question
Sure.
about from Korean. What is max workers?
Yeah. So max workers basically is the number of threads that can run at any given point in time. So I told you about, right, thread pool executor, right? So you have threads, and then you have a pool of threads, and then there is an executor which is taking your task and executing on those pool of threads, right? So what we have said is that the maximum thread that we can have is denoted by max workers. So if you say 5 here, what it means is that there can be a maximum of 5 threads that might be running in that. Okay. But there will be going to be 160 tasks here, right? So what it means is that once one task is getting preempted, there could be 4 other that can take control over it, right? And not 160 that are competing for that thread or for the control.
Great, please carry on. We have 5 minutes left.
So we'll talk about async IO. So async IO, there's something called an event loop. So it controls how and when each task gets run. Event loop is aware of each task and know what state it is in. So let's assume a simplified version of event loop, which has 2 states: ready to work and waiting for external things, right? Event loop have other state, but we are using a simplified event loop. So your simplified event loop will maintain 2 list of tasks, each one of each of these states. And your simplified event loop select one of the tasks and start it back to running. So basically in async IO, the task will say that, I'm ready for work. I have stopped waiting, or they will pronounce or announce to the rest of the system that we are waiting for some external thing like a network call, right? When the task give back control to event loop, the event loop places the task into the ready or waiting list, and then goes each of the tasks in the waiting list to become ready for IO operation. So let's quickly talk about some of the keywords that are there. So there are two keywords that are available in Python: async and await. It is a flag to tell Python that basically this function will wait, right, or it will await. The other use that you can do for async is async IO, where you can have a context manager where the context, the things that you're doing in context will await, right? So awaiting means that you are waiting for a function call to get over, and it is also a signal to the event loop that I'm waiting now, and you can give back control to some other task that is looking for for the control, right? So as you can imagine, there is some complexity involved, and we will talk about that in the example here. So let's go over this example here. So similar stuff in the main. What we are doing is we've created an async function. So it tells Python that this is going to await at some point in time. We have put in an context manager with the async to it, and we've created a client, a session. And for each of these sessions, for each of the URLs, what I'm trying to do is I'm trying to create a list of tasks. And I'm trying to tell the async system to basically run this method here. So now this method will going to call session.get. Now, so session.get here will call some await at some point in time, right? And what I'm trying to do is, so basically this loop will get over, it will start this thread and move on to the next item, right? And it will gather all these things. Now what async.gather does is it will basically wait for each of these tasks to get over, right? And basically what you're trying to do is you're trying to, with this, you are trying to basically populate in your simplified event loop, you are trying to populate the list where that are ready for picking up the task, right? Now what event loop will does is it will basically see all these tasks and start execution with one of them. And as soon as the wait start, right, this particular thread, this get, will say that I'm waiting for something and you can take control from me, and the next task will be picked up, right? So if you see here, for 160 URLs that we've done, right, we have done this work in 3.4 seconds, right, which is faster than the threading version. It's not very fast, but if the number of problems that you see, the number of things that are there, right, if the number of tasks increase, this will going to outperform the threading version, because you are able to accurately give control back to the other task as soon as you start waiting, right? You are not on the mercy of operating system to interrupt you, right? So it's going to be much faster than threading, and as the size of the problem or size of the wait is going to increase, this is going to outperform the threading version. What it also does is, so the other thing is that you don't have to decide the number of thread that you want to run. It is being taken because at any given point in time, only one thread is running, and basically there's a perfect overlap of wait. You don't have to do that mathematics hit and trial to figure out the number of threads. The other thing that it does is it basically pushes you to think about your software design, where you know that over here there will be a wait, and that will basically pause this task at that point in time and give control to other tasks. And it's again going to be much more scalable. What are the problems with async IO version? So with async IO version is that we are using a special library, right? We are not using requests anymore. We are using AIO HTTP. Now this basically is doing very similar thing, but it basically has await in them, right? Which can be a problematic thing because async IO support came in Python very recently, and we don't have a lot of libraries. For HTTP requests, we do have libraries, but for others, there isn't a lot. Right. The other problem with this version is if suppose one of the one of the tasks, does not cooperate, right? If it takes the control and never awaits, right? What it means is that you are scaring other or you're creating a scarcity, right? Because it is not giving away control, right? So that could be a problem. So you can have issues or a minor mistake in code can lead to scarcity to other tasks and cause a lot of problem. So there is a lot of planning required to do this, but it is going to be much better than threading example. It will scale better. But if one programmer did something bad, right? If one programmer basically is not giving away control, then rest of the threads or rest of the tasks will basically not get control until the task is over, right? I'll move to the multiprocessing example, and very similar example, but we're creating multiple processors. This is pure concurrency, because you have multiple processors, and each processor is running a different process. Code looks short than async IO. Microprocessor processing on high level create new instance of Python interpreter to run on each CPU, and then farming out of your program to run them. Now, because it's launching a new Python interpreter for various instances, basically you will, sorry. Because it's creating a new instance of Python interpreter, it will take a lot of time if the problem set is really small, right? So the other thing to see is that obviously the results here are much better than the synchronous, but worse than threading and async IO. And that's because there's a lot of overhead to create a new Python interpreter on each CPU, right? But there are obvious advantages. It is obviously better than the synchronous approach, but slower than async IO and threading. And so those are the things that are with the multiprocessing option, right? I know that there are some questions. Let me take those questions at the end and run through the presentation once.
Yeah, we're almost on time, so maybe we can try.
So we'll quickly talk about how to speed up a CPU bound program. So in this, we're gonna be doing a silly thing. We will not have a very heavy CPU heavy task, but what we're gonna do is we're gonna create a function to basically sum of squares of number of n numbers, and so that's going to take a lot of CPU bandwidth, right? So if we talk about the synchronous version, this is the method, right? This is a CPU bound. What we are doing is we are doing a sum of squares of a number, right? So over here we've taken a very big number, and basically on those big numbers, what we are trying to do is we are trying to find the sum, right? And so that's where so there are going to be 20 big numbers, and you will be, for all those 20 big numbers, you will be basically trying to return the sum of squares from 0 to that number, right? Now, if you see, the synchronous version takes 9.2 seconds. It's decently faster than it's a big calculation, but CPUs are much faster than this, right? So if you don't do such a big calculation, CPU will return the result very quickly, right? So we want a very computational intensive task. Single thread, it's all running on a single CPU with no concurrency. So let's think about how does this perform on a threading in a async IO. So I have not done async IO here, but I've written the result here for async IO. Now, because there is no await that you can do here, right? Basically, there's no speed up that you're gonna get, right? Because there's no wait that is happening, and async IO and threading basically try to overlap that waiting period. Now that is not happening here, so you will not see a lot of benefit. So the timings are very similar, right? Again, thread pool executor is there, and we've kept the workers at 5. Even if you change this workers, right, it will not make a big difference in the time. It will make it actually worse, right? If you increase the thread workers even more, the time will increase, right? Now it's 9.2 here, and it's very similar, right? It's again 9.2 in threading and async IO. The async IO example is there on the GitHub repo. You can check after the call. Now things starts to get interesting with the multiprocessing here, right? So the speed up is like really great, right? Now from 9 seconds, it's like 1.5, 1.6 seconds, right? So what we've done here is we have just created a pool of processes, and for each for each of the CPU bound tasks, we are creating a new process, and that is going to run in parallel, right? The good thing about this program is that it takes full advantage of your CPU power on your computer. If you have multiple processors, it will run those onto different processors, and you will get that benefit, right? Right. So the other thing is split. The obvious challenge with this approach is that because you are creating the problems are separatable, right? However, it is sometimes difficult to basically divide the problem into sub problems, right, which can run independently, right? So that is one problem. So if you calculate the value of pi, right, which is the computationally heavy problem, right, there are going to be values that will be calculating, but there is some part of the problem that you can't solve independently, or they can't run on different processors, right? The other thing to note here is that the overhead of creating new processes is much less than the amount of work that you're doing in the CPU bound task, and hence you are seeing the advantage in time, right? So we'll quickly move to the conclusion aspect of this. So I think we covered a lot of ideas and decision point. To summarize, I think the idea is that for IO bound tasks, threading and async IO does help, right? And so basically, if your task does not run very frequently, or it is within SLA, you don't want to do any concurrency, right? That's the first thing. The second thing is, if your task has a lot of IO, then threading and async IO are a great place to start. Async IO will beat threading. It will be much better in longer run. It will scale better. However, if you have a CPU bound task and you can divide that in such a way that they can run on individual processor, multiprocessing can actually help you there, and that will give you the best result. So we are moving into the last portion of the presentation. Do we want to do the Q&A right away, or do we want to wait till the end of the meeting?
Let's take a couple of questions, and the rest we can take offline or in the open house session. If anybody has any questions, feel free to just unmute yourself and speak. If not, Panchal will be here till the open house session, so we can have a healthy discussion around this as well at the time. Thank you so much, Anshul. It was really good talk. Okay, so moving on to our next speaker, Rakshit. Rakshit, if you're here, feel free to share your screen. Come online here. Rakshit will be talking on a starter's kit to federated learning. It's a very interesting topic, and we hope to learn a lot of things about federated learning today. Rakshit, are you able to share your screen?
Yeah, can you hear me?
Yeah, we can hear you.
Okay, yeah, I'm sharing my screen right now.
Okay, cool. If you have, for everyone, if you have questions for Anshul also, you can paste them in chat as well during the time, if you feel.
Can you see my screen?
Yes, okay. Yes, Rakshit. Over to you.
Yeah, okay. Thank you, Aniruddha, and thank you, Anshul, for that awesome talk. So let me start off with my talk, that is on a starter's kit to federated learning. A bit about me: I'm a senior at Manipal Institute of Technology, and I'm currently interning at BlackRock, and I'm an incoming master's in privacy engineering student at CMU, and I'm also a research engineer at OpenMind. And before the talk starts, let me just share you some links on what you will be requiring in order to go through this talk, because I'll be giving you a tutorial on how to run uh, federated learning on Colab. So let me just share you those links out here. Yeah. Okay. So let's get started. So let me give you a brief introduction about artificial intelligence. So uh, artificial intelligence actually encompasses both machine learning and deep learning. You can say that AI is kind of a very naive term when you talk about machine learning and deep learning. And machine learning actually allows you to run some statistical algorithms on your training data, and and you can inference them on the and then learn through that training data onto the testing data, while deep learning actually involves neural networking and is also a subset of machine learning. So right now, machine learning models have really become more and more complex. Back in 2016, uh, BERT was a really complex model, and it was on top of the leaderboard for language-based applications. And right now, BERT is commonly used and widely used for NLP applications. And with these advancements, it's also possible for models to learn more than what's necessary, and they could also learn on sensitive information. So I really like talking about this story back in 2006. That is the Netflix, the $1 million prize by Netflix. What happened was that they had this data set, and there were two researchers from UT Austin who were able to de-anonymize the data set uh, and actually retrieve information, sensitive information like credit cards and whatnot of the users, of Netflix users. So what they did was that Netflix provided a data set with all the recommendations and the likes and the reviews of the users, and these researchers, they actually cross-reference this data set with the IMDb data set, so that whatever whatever user liked one particular movie, they could cross-reference it with the IMDb data set and de-anonymize that person's information. So this was actually a very huge breakthrough in the privacy field, and ever since then, differential privacy has become really important. Uh, and there was also this incident back in the late 90s where the Massachusetts governor's his vote was actually uh, decode, decoded uh, backtracking backtracking his dental records. Yeah, and that was very interesting. So let me get back to this talk. So here, this is machine learning for production. So what we do is that we actually take the client's data and we actually upload it onto a server. But what happens if the server is malicious or the server gets compromised? So this is it's a huge risk to private information of the clients. So this is how traditional ML models are deployed. So Google came up with an alternative approach called federated learning. So what happens here is that the machine learning models on the user side, they can be trained locally and also evaluated locally. And only the summaries of these models can be shared to the server, where they are aggregated into a new model, and these can be deployed back again to the user devices. So this is the Google's breakthrough paper on federated learning. And yeah, here is a simpler image for displaying what federated learning is. So you have clients, and each client has a model, and only the model summaries, that is the model updates, are sent to the server, so that these model updates can be aggregated, that is averaged, and only one single update could be learned by the server rather than the entire model updates within the protocol. So what is federated learning? So how does it work? Here you have many devices, that is many client devices, and uh, each of them run a model on them, and as I said, only the gradient updates are sent back to the server. And here the server actually averages all the gradient updates, and only the averaged update is learned by the server. And this is again sent back to the clients for and repeated over a several number of rounds. So there's this very fun comic by Google that actually explains federated learning in a very simple way. So you can go through it. So the properties of federated learning are that it's non-IID, so that is non-identical and independently distributed. So the training data is actually dependent on the usage of the mobile device by that particular user. So this means that the data could also be very unbalanced, because some users could heavily use a particular app while the others might not. And these are also massively distributed, because sometimes you have a huge number of clients over the entire protocol, while you don't have the enough number of examples for per client. And this also gives rise to limited communication, because you often want mobile devices to be stable. And federated learning is only carried out when certain properties are met by that particular mobile device. Example, that it should be charging, and then it should be idle, and so on. So even limited communication is a really important property of federated learning. So there's a tutorial on federated learning on the MNIST dataset. So I've shared you the link for that tutorial. You can follow the instructions on how to run that particular notebook. So let me talk about the MNIST dataset. So the MNIST dataset is a dataset for handwritten digit recognition, and it has 50,000 training examples and 10,000 testing examples. So with respect to the tutorial, let's first load the MNIST dataset. So out here, we just loaded from Jan LeCun's MNIST repository, and then we divided into training and testing. While the next function is the visualizing function, where you can actually visualize the MNIST data train and the MNIST data set. And then you can actually partition the data into IID and non-IID settings. So by IID, what I mean is that you can actually shuffle the data and then split it equally between all the clients in the protocol. So this means that each and every client gets the equal number of data, but this is not very realistic, but it's very good for simulation purposes. While non-IID data is actually quite realistic, because here you can actually sort the data based on the digit label, and here you can also divide the data into n different shards of a size S, and each client will get a particular number of shards. So this way you can say that uh, it's kind of improving the data imbalance, the non-IID-ness of the setting. So yeah, here I'm talking about a very simple model, that is the MLP model, the multi-layer perceptron. Here there's only 2 hidden layers with 200 units each, as you can see, and we use the ReLU activation function. And the next one is the federated averaging protocol. Out here, what we do is the client update. The client locally runs um, the model, and only the model summary, that is the model state dictionary, is sent back to the server. And this is normal machine learning process, where you can actually clear the gradients and then make a forward pass, calculate the loss, and then only the average, you calculate the average loss, and then the loss and the model update is sent back to the server. And on the server side, yeah.
Sorry to interrupt, Rachit. I think the code is very small. Can you zoom in a bit?
Oh, okay.
It's an image. It's okay then.
It's an image, yeah.
It's okay.
I
Carry on.
can, yeah, you can probably see it on the on that notebook that I shared, if that's okay.
Perfect. Sure. Please carry on.
Yeah. Yeah, on the server side, what you have is that you get the client update, that is the model update from all the clients, and you average it out here. And uh, once you average it, this is actually sent back for another round. So you run this over a particular number of rounds, and then you get a really good average model, a generalized model on the server, in order to understand how the uh, uh, entire client space is faring in terms of that particular machine learning task. So uh, let's move over to testing, and then the testing should be the testing is quite simple, because here also what we kind of do is calculate the test accuracy and the test loss. And here you can see that yeah, here you can see that we actually print the final test accuracy. And even if you run the federated learning model for one round, it really gives you a really good accuracy, somewhere around 94 and 95%. Yeah, so now here you can train on the IID uh, in the IID setting. So MNIST, the 2NN, that is the MNIST MLP on the IID setting, and you can run that code, and it should be running for a particular number of rounds. I think it was 10 that I set it out there. And yeah, here there are some symbols. That is, C refers to the client fraction. So you can actually select a subset of the clients that are within the protocol, so that you can say that for that particular round, only those number of clients are active, and only those number of clients will actually send an update back to the server and will be active in that protocol in that particular round. While K refers to the total number of clients in the protocol. So you can see that C into K actually gives you the active client space in that particular round, uh, while E refers to the local rounds within the client. So the client can actually run this locally, but we really don't want to put that for a high number, because that means that the model could be more personalized, and could also learn on sensitive information. And here's the batch size. I set it to 10, and a learning rate of 0.03 was found to be really good on the IID setting. While for the testing, you can this is a simple function where you can actually get the test accuracy, as I explained earlier. And the next one is training in the non-IID setting. So in the non-IID setting, as I said, that you have the total number of clients, which is 100, and you divide it into different number of shards, so that the clients get some particular number of shards. So out here I set that, so we know that there are total number of 60,000 examples within MNIST. So what happens is that I've set each client to get only 2 shards. So 2 shards, and then they have a 200. 200 is the number of is the total number of shards that you get in the end, because 2 into 100 gives you 200, while as we know that the total number of examples within MNIST is 60,000, and 60,000 by 200 gives you 300. So this means that the size of each shard is 300. Okay, and the total number of shards is 200, and you have the 100 number of clients, and each number of client gets 2 shards. Yeah, and this is the testing example with non-IID, and that's the tutorial. I've also included one more network called MNIST-CNN. That is a much more complex version of the MLP, and it and this actually converges really well, even if I have less number of rounds. So let me talk about something called Flock. If you have been reading the news recently, Google actually disabled third-party cookies, and they've actually suggested uh, an alternative for this, which is called Flock, that is federated learning of cohorts. So there's a controversy on this because some people are saying that it's good, some people are saying that it's bad, and this is an alternative to third-party cookies. So what happens is that users who log into Google, they actually get grouped up into into a particular cohort. So this way, whenever you get targeted ads or targeted media, so it's particular for that cohort and not particular for that user. So when you get grouped up within that particular cohort, it actually facilitates for more privacy. And um, this is really good in my opinion, but there are other privacy based browsers like DuckDuckGo and Brave that actually say that is bad because you automatically get grouped up into a cohort without even knowing that you are in that cohort, and you get targeted advertising for that particular cohort and not uh, yeah for that particular cohort and not which is not relevant to you, right? And yeah, so that's about it. And this is a teaser for my next month's talk on visual interpretability with CAMs. So next month I'll be talking on what CAMs are, what class activation mappings. This is on explainable AI and interpretability. And we can see that there are many CAM methods, that is GradCam, GradCam++, Smooth GradCam++, and ScoreCam. And our paper on SSCam actually gives a more enhanced or sharper visual representation of all the other camps that have been released. Yeah. So in conclusion, uh, federated learning actually allows centralized training over decentralized data. So this actually preserves data privacy, and you can gain generalized insights over the active client space. And this can also be applied to various problems, and it's very prominent in healthcare because uh, you always have that doctor patient confidentiality and so on in when it comes to healthcare. And there are many policies uh, on privacy right now, on like GDPR and even HIPAA, that is the Health Information Portability Act, which actually doesn't allow you to use patient information in a malicious manner. So federated learning could actually also be combined with other cryptographic techniques like secure MPCs and differential privacy and even homomorphic encryption to enhance privacy. And I also want to say thanks to Ayush Agrawal for his federated averaging implementation that I just described. And yep, that's it. Thank you.
Yeah, sorry to interrupt. I have a question. So can you go back to previous slide? So in that slide, you have said that the federated learning can be useful in healthcare, right? But in healthcare, we usually prefer high recall, right? But what we are doing in this is we are sending the parameters after the maybe whatever algorithm we are using. So maybe gradient descent. So we are sending those parameters back to our server, and then we are calculating. But we need high recall, right? So if we send the actual data from all the client and then we will train the model, then it is supposed to be better model, right? So there should be a trade-off between them, right? Like if like there should be trade-off between accuracy. That's what I think in both the cases.
There is a trade-off between accuracy, surely. But what happens in federated learning is that you can actually keep the patient data on your device itself. So you don't want to upload it onto a server where it could be used in a malicious manner, or it could be used in a harmful way. So you can actually keep your own private data within yourself, and only the model updates can be sent to the server. So this way you can actually prevent some communication cost also, that is by sending your data to the server. And this has actually shown really good results in healthcare, because right now there are some papers that are specific to federated learning in healthcare called split NNs. So what they've done is that they've actually split the neural network into different devices, and this network can actually train locally on each of the clients, and then combined back in the server. So it's very cool, because that was a very recent paper. I think it was just last year, released by the MIT Media Lab. Yeah, I'd suggest you to look on it if you're really interested. Yeah.
Yeah,
Yeah,
sure.
I mean, this is really interesting. Another question on the, I mean, if you have the data, then you can really look at the quality of the data which you've used for training the model, right? I think, but now
Yeah.
we give only the, like thing, and the data will be used within the client's device. So we don't know whether the quality data has been, what kind of data has been used to really train this model, right? Then we
Correct.
try to
Yeah.
aggregate that will have an issue on the final model or
That could
parameters.
actually, yeah, you're right. So,
So is there any paper which demonstrates the trade-off between both the methodology?
yeah, there are actually some papers that talk about Byzantine robustness in federated learning. So what happens is that the clients could be malicious, and they could send, some random malicious update back to the user and back to the server, and the server could, aggregate all these updates, even though it has some malicious updates, and this could really give a bad accuracy in the entire model. So there was one Usenix 2020 paper that actually talks about uh, local model poisoning attacks within federated learning. So I can share you the link if you want for that. Yeah.
Yeah, sure, that will be great.
Yeah.
Thanks.
Thank you.
Yeah, hi Rakshit. This is Ravi here. So, like for federated learning, like as you said, like the data will be like in encrypted form, right? So, I mean, a client can use, the data just to check that thing. I mean, to train the model also, right?
Yeah, it's not exactly encrypted, but it's actually kind of in a plain text form only on the client side.
Okay.
And because they are trained on the client and only the updates are sent, so this way, and the updates actually have, garbled information. So if you have seen the gradient updates, it's like 0.01, 0.1, and so on, right? So you cannot exactly understand from what you get with only with these gradients. So so that's how you kind of preserve the privacy in federated learning. But as you said, you can also encrypt the information and try it out with federated learning. So there have been papers that use homomorphic encryption with federated learning. So what they do is that they homomorphically encrypt the data on the client side, and then they train it, and then they send the updated encrypted updates back to the server, and then that encrypted update is used for averaging, and the rounds continue.
Okay. So, like whatever the example you were showing that was related to the deep learning. So, this federated learning can be applicable for machine learning also, right? I mean, if you
Right.
want to do ensemble learning, yeah.
Yep, surely. Yeah.
Okay. Yeah. Thanks for the answer. Yeah.
Thank you.
Thank you so much, Rakshit. Do we have more questions for Rakshit? If you have a question, feel free to post it on the chat or unmute yourself and speak up.
Thank you.
Okay. Thank you so much, Rakshit. So we'll be taking a short break, and we will return. So since we got a bit delayed from the exact timeline, we should be back by how much time should we take? 5 minutes break, and we can return by 11:50 for the next talk with Shashidhar. In the meantime, I'll be sharing a few links here. So this one is the Bangpypers blog. We post about our past meetups and events details. So if you have missed out on something, you can probably catch up here. We have a few volunteers on this call as well, on today's event as well session. There's Ritesh. He's also one of the co-organizers. There's Rahul, and there's Arun, goes by the name Geospec. Also, I mentioned about the PyCon India CFP is open, so here is the link for that. So the Python India is currently accepting talks and workshop proposals. So if you are working on something you want to present at an international conference of Python, feel free to do so. Will return shortly. We also have a feedback link, which essentially we share towards the end. We have only one talk, so you can probably share some of the feedback of these two talks right now. Okay, Ritesh has shared the link here. And also, you can like this is an anonymous feedback for us, so that we can improve and so as to bring a better event next month. Sorry about that. So we'll take a quick 4 minutes break and see you back in at 11:50. In the meantime, if somebody wants to discuss something, feel free to unmute yourself and talk. Feel free to, the chat is also open.
Hello. Shashidhar sir, are you there?
Hey, Abhiram, I'm there.
Hi. Yes. Thank you for joining. To everyone, in case it has not been already announced, I'm sorry, I have been occupied with another meeting, but I will catch the recording for the first two talks. Shashidhar sir will be talking next about LP problems and how to work with them in Python. So that is the next agenda. And it's going to be pretty interesting. If you remember, we had a talk for people who have been regular. We had a talk sometime in December of 2019 or sometime in 2019 on the topic. Probably not much of an overlap today, but if you were there at that time, it'll be good to see what sort of like connections you can make with the learnings we have from Shashidhar sir this time. How many of you have been attending Python meetups here with Bangpypers for the past, let me be optimistic, 2 years? I should not have been optimistic. 1 year? Raise your hands. What? Ah. Kurian, you have been in couple of meetups, right?
I think you are asking at the break time. Probably people might not be there at their desk.
Possibly. I think breaks for an online thing is not a great idea. I mean, that's what even Ani and Ritesh were discussing here, because attention spans tend to drop.
Yeah, in offline it used to be snacks plus networking time.
Yeah. Now if people have snacks, they'll just go out.
Yeah. Oh yeah. Also, we like about the job posting thing. Ritesh, do you want to take?
Yeah. So we have introduced a job posting platform, like added feature also on the website. So let me share the link. Okay, Anirudh has shared on the Zoom chat. So if anyone in the organization is like here is hiring, so feel free to put it there so that we could announce it later on, publicize it via our channels. And in case if anyone would like to mention something about it, like just add it in the chat. So maybe we can plan accordingly. Like you can just tell about the role and company in like 10 to 15 seconds. So that would be about it. But yes, we will certainly like add your job posting here, and we'll be posting our social channels and we'll be informing you regarding the same. Because like this is one of the like community effort that apart from the talks and like increasing the knowledge networking, so it is also one of the community responsibility to bridge the gap between, like, if anyone is interested in job and any organization is hiring. So I would say this also comes into the community responsibility. Anirudh, Abhiram, you want to mention anything else?
No, I think that should be it. If you're looking to hire, this can be a great way. We initially had been getting a lot of one-on-one things, so we used to connect people, but eventually we realized we don't have a very good memory, so we ended up forgetting who's hiring and all. So this can be a good place to get them connected. Abhiram, do you want to take it ahead? We are almost off time, off break, so we can continue with the next topic.
Yeah. Sure. So about the job posting things, yeah, Ani and Ritesh have already covered everything. It's also that we would get a lot of these one-off mails on the news mailing list that may fly under the radar because it is not it's not given enough importance, or it just gets missed. So we will also try to push it from other sources. And now for the third talk. Shashidhar sir is not a stranger to anyone who has been attending the meetups. He's been very helpful in terms of giving us a lot of workshops and talks around data science and a lot more concepts. So today he's going to be talking about solving LP optimization problems using Python. I hope I remember the title correct. Yeah, Shashidhar sir, over to you.
Thanks, Abhiram. So today, what I'm really going to cover is on the first piece is a little bit of, maybe a bit dry on the subject itself. But once you really have understanding of the linear programming, like we'll get into how Python can be used and what are the different things are available, both commercially and then open source. And also some of the use cases, probably, like interesting use cases that we can really talk about, saying that, in the real world, what has been solved by these kind of things. So the primary motivation for me is I've been doing a course in IISA. I thought maybe, whatever I learned in a few months, I can come and talk here. I'm not the, like a expert in the whole area, but if there are questions which I cannot answer it, definitely I can get the answers later. So with that, introduction to analytics, right? I mean, this is being there in the industry. If you really look at it, there are a lot of text there, but you don't have to really worry about it. But primarily the decision making, right? In the enterprises or corporates, you have a lot of data and a lot of things are happening in the organizations, and then you really want to make the decisions, data-driven decisions. So the analytics is, is developing actionable items from the data. Again, there are a lot of things like you collect the data, like aggregate this data and apply a lot of statistical and machine learning, operational research, like techniques on top of it to really get insights out of data. So why analytics is important? Let's take as, like a use case. You probably might have heard the Akshay Kalpa Patra Foundation, right? They provide, like midday meals to underprivileged school children, 1.4 million children across 84,000 schools and school children and 650 schools, and they have 35 vehicles. So these 35 vehicles have to be routed in such a way that they get, like an optimum coverage to serve these meals across these schools. I mean, if you simply think of hypothetical method in the sense like, this many schools, what is the problem translate to? It is a, like number of routes or as possible solution space is, like 2.43 into the power of 18, that is 20 factorial. And even if you have a very good computer, which is going to really do 1 million requests per second routes, it is going to evaluate. It takes so many thousands of years to really complete the whole possible routes. I mean, TSP is nothing but a traveling salesman problem. That is the complexity. So, I mean, in the real world, there are many use cases where, you have complex problem to really solve, and then these techniques are going to really help. And this really evolved a lot in last few years. Okay, so with that, the business analytics, right? So again, to gain insights of the data and to make the decisions, forming a business problem. Actually, it is very, very important. There are three things inside this business analytics. One is the business context, technology, and then, the data science piece of it, right? So, example, like I think this is one of the example, bigbasket.com has implemented this feature, but without the feature, there was a lot of, probably they're not optimal. Basically, what happens is many of the customers, when they really create this cart, they forget some items. Particularly, they really, like order these items on a regular basis. But even then, like if you look at, there is 30% of the items they intend to buy, they really forget when you really place an order. I think this is some study that at bigbasket.com, and they want to really implement a feature, to really say that before the customer places an order, you want to say whether did you forget anything. I mean, this feature alone can really help them a lot, both in logistics wise, because even for the customer also, there are no multiple shipments in all of them. And even the logistics wise, it's going to really help a lot for the big basket, this one. But so even if you want to solve this kind of problem, how can technology is really going to play a role? I mean, you need a lot of data to really understand what kind of items, what kind of people are really, what kind of items they're really forgetting. Like you need to collect a lot of this data before we really go back and do the recommendation to the, like users. So there are a lot of the data science, there are a lot of areas are there, machine learning, deep learning, statistical algorithms. But in this particular talk, we focus a little bit on the operation research techniques, which are, and in one of them is the linear programming, basically. So that's what is the focus today. Okay, so quickly, I think there are three different type of, like analytics are there: descriptive, predictive, and prescriptive. The operation research and optimization falls in the prescriptive area. Here, you have all the data, but you want to really make the decisions. I think the optimal decision that you really want to make, the business decision. So whereas descriptive is to really look at the past history and see what has really happened. In the predictive area, you look at the past history, but you want to forecast the future and say what is really going to happen. What will happen next. So, or why will it happen also. Okay, so I think there is during this decision making process, one of the important thing is the model formulation, right? So when you talk about model formulation, it is the representation of a business in different ways, a concept, an idea, or a system that is existing, you want to represent in a model. There are different ways that you can really represent. Iconic model is like, it is the same physical form you are representing it, but it is going to be a scaled version of it. Like you are really prototype building, people really, like how it really looks like, or even a map or a drawing that you really put on paper. All these things are iconic model example. Analogous model, it have the characteristics of that, like system, but it is not exactly what it is there. So histograph will tell you some of the characteristics of the, like process, but it's represented in a different fashion. Symbolic or mathematical model. So this is where, like a lot of operational research, like we express all the problems in that terms of mathematical model. So I think some of them it's okay, but let us look at, some heuristic, deterministic and stochastic. These are the, like other important thing. I mean, rule of thumb, probably if the heuristic is used a lot in many of the areas, right? I mean, people, when they're cooking, I think they know if I have this many glasses of water and what should be the salt, I need to really put it. There is a thumb rule. I mean, they really go and apply that kind of thing. There is a heuristic model. You have a thumb rule based on some intuitiveness. And deterministic model is the environment is not changing. Any point of time, if you really take an action, you'll get the same output. But stochastic or probabilistic model is the environment keeps changing, and then each time you really try to do it, you'll get a probability of something really happening. So static and dynamic models are the ones which are, one is a point of time static model. A dynamic model is going to be more of a series of, time horizon. What are the things that are really happening? So, I mean, this is a very high level context of before we really get into the operation research. The business analytics is really, there in many of the organization, going from a very small, medium shop to, big organizations. Everywhere the business analytics is really important. Okay, so now quickly look at what are the typical problems that we really solve with these kind of techniques. So these are the application areas where in the manufacturing you have a optimal product mix. I mean, if you know the coffee, there are a lot of different blends that they really make, for making the coffee, and each of the blend costs different things. And then, what kind of a product mix is really going to give me an optimum at the lowest cost, but a good product. Raw material mix. I think if you have a lot of different raw materials, and then the raw materials is a constraint that you really have, and which product, what raw material I should really use it, that is one. And then production planning and scheduling it. You want to really produce things, and in next few months, what should I really produce, and how much should inventory I need to really keep it to meet my demands, kind of thing. So logistics, I think this is going to be a very big, supply chain management system, vehicle routing and all of them. It's used everywhere. Manpower planning. I mean, if you have, people, number of people are there, how many people are required. Particularly, you have a flexible resource where you are really giving a contract where you can really hire and then, take the people outside. How many people you need at different points of time, you can go and do it. In the finance, there are a lot of applications. Actually, I work for a financial services company, and we use this in the lot of quant models building. So these quant models are, based on the so many parameters, and every day you really go back and try to figure it out. This is actually a trade-off between risk and return. How much risk I should really take it for a kind of return that I really, get. So this is an optimal investment decision, right? So it's similarly, if you take any investment process, I can put in equities, but if I put in equities, I'll get a good return. But if I put into, fixed income products, I get a less return, but they are more safe than equities. But how much I need to really put to really balance that, risk and return is a major, decision. And working capital budgeting, and all of them. And marketing, what advertisement, if I really do the advertisement, in these different channels, what is the conversion rate, and, which is the optimum thing that I need to do it for the cost that I'm really going to incur. So again, if you look at the right hand side, there are different techniques that they really apply. It is not just the linear programming. Linear programming is only one of the techniques. And next in the linear program, you have integer linear programming, mixed integer linear programmings. And also people use forecasting, and a lot of simulation things are there. And then even Markov decision models. And even linear programming has two things. Another one is the non-linear programming. People use that non-linear programming. Also, particularly in the finance, there are a lot of cases people use non-linear programming. Okay, so with that, if you really look at it here, there is a mathematical model that you really built, which is this mathematical model is going to be the representation of this your business contract or a system. For this, you have two inputs. One is the controllable inputs, another one is the non-controllable, uncontrollable input. So the controllable inputs is, for example, if you take a manufacturing case, you can really say how much you can really manufacture, of how many quantity that you can manufacture for a particular product. But controllable is like you have a machine capacity, or you have a raw material. Raw material is not abundant. You can only get so much of raw material that you can really, you have to work with it. So if these are the two inputs for a mathematical model to get an output, which is going to mean what quantities that I really want to produce. Okay, so I mean, again, the mathematical programming is a way of representing this whole system, like system of this equations, in the mathematical form. Okay, so any problem that you really take optimization problem, there are a couple of things that we have to really look at it. One is decision variables are the ones which you want to make a decision on. If you take a, Akshay Patra, like the example, if you really take it, there are so many vehicles and there are so many destinations, and you have to assign a particular route to that vehicle, right? So what route to be assigned to which vehicle is your decision variable. You have the constraints, and you have the objective function. Objective function is to reduce the cost in this particular, like scenario. You want to make sure that you reduce the cost so that you deliver the same vehicle can deliver to multiple places without incurring a lot of cost. And constraint is you have how many number of vehicles are there. Some vehicles can really go in certain routes, some vehicles cannot really go in certain routes, and all of them. And non-negativity is that all your decision variables are going to be greater than 0. They are not going to be negative. So I think this, if you take any business context, you need to come up with these 4 things before you really go back and put into programming. So once you have these things defined, then you really go back and write a program and solve the problem. I mean, I don't have to go through. This is what I've really explained in this one. In the mathematical form, if you're really trying to put this, like a general form, if you're really putting it, maximization or minimization of, like of a function with all these decision variables x1 to xn, subject to the different functions, which are these, restrictions or constraints. Each function has, like the same set of variables what we really have, but it has been restricted either greater than, less than, equal, non-equal, or less than, greater than, like to a particular value. And all these functions are in linear relationship. Then the problem that is going to be you can solve with the linear programming problem. But if any one of them is non-linear, I think it's going to be a non-linear optimization. And non-linear optimization is going to be more tough to really solve, or maybe like complex to really solve than linear programs. Okay, so before I go to that, any questions or any thoughts around that? Okay, so
the questions will come, sir.
Yeah, okay, no problem, no issues.
Yeah.
Again, as I mentioned, linear programming is you have an objective, either a minimization of like a cost, or maximization of your profit, or minimization of your distance to be traveled, things like that. But the objective functions with a given restriction, like constraint that you really have, you are going to find what are the optimal decision variables. So a bit of history. I think this has been started, like somewhere 1826, 4-year, formulated a linear programming. Kandrovich is, like a Russian mathematician, and then along with another person, I think got the Nobel Prize also in the field of economics. So I think the 1939, actually when it is really picked up is in the World War II, when 1939 to 1945. During that period, the problem they want to solve is the large-scale military operations, particularly these routing problems, like trying to send a lot of these vehicles to different places, and like how do we really optimize that piece. I think it started there, and then after 1945, 1947 is the where it's a turning point. Danzig is like an American mathematician. He's developed this simplex method. I mean, out of all of them, even today, a lot of them use the simplex method to solve the linear programming problems. Yeah, Koopmans and Kandrovich, both of them got a Nobel Prize in 1974, I guess. So, I mean, these are the famous names, are people who are really involved. Today, I think it's like with the way that we have the data and all the computing power, I think things have a lot changed. And recent was the Karmakaran, I think, as the new polynomial time algorithm for linear programming. Even then, I think the simplex method is much more famous than any other things. Okay, so let's get a, we'll take an example, probably bear with me for a few more minutes on this, like a simple, because these notations are important when you even go to formulate the problem. You're maximizing or minimizing an objective function with all these variables x1 to xn with the coefficients of c1, c2, c3. All these are the, either cost, revenue, whatever, that directly, influencing the objective function. And you have a lot of constraints, m constraints are there here. And a11, a12 are all the coefficients for these constraints. And then, you have a right-hand side they call as b1, b2, b2 up to bm. So, and all the variables x1 to xn are going to be less than. I think you can even solve for negative as well as unrestricted sign. URS is an unrestricted sign. Basically, we don't even know whether it's going to be positive or negative. But obviously, as you really put these constraints, it's going to be more, difficult. So, simple question: what do you think is, is difficult to solve? If it's a constrained problem, is it difficult to solve, or an unconstrained problem is it difficult to solve?
Unconstrained.
Why unconstrained is difficult to solve?
Because there can be any number of solutions. Constrained, you know where to limit, so you know that it has to lie within a certain limit, and you can zero in on at least a set of solutions.
Yeah, absolutely. So, I mean, that's the reason that it's easy to solve the constraint problems, because you know what is your feasible vision that really comes in, and then there are only this many, probably maybe not be one optimal, multiple optimal solutions also, but limited. But if you have a lot of unconstrained, I think you have all the resources in the world and you have everything that you really want to do it. There may be so many optimal possibilities, and it's going to be difficult to solve it. This is the same thing expressed as a mathematical notation. I'll go to this next slide. Maybe it will give you a better representation of it. Right? The same linear problem, and we can express in the matrix form, right? So all these coefficients for all your constraints, a1, 12, like a1, m, a, m, n, and like m constraints, and then n variables, and then x is the decision variables that you really want to solve, and b's are the right hand side. So it's basically simplex form is a x equals to b. A is a matrix, b is like a vector, and then x is a vector. But basically it's like a into x is equals to b, and you are solving for x here. This is a way of representing the linear equations. System of linear equations. I think all the problems will boil down to like this form. I mean, again, not all the coefficient need not to be having a value. That some of the cases, many of them are going to be zeros, and some of them are only having values as such. Okay, I think it's very, very important to understand what are the limitations when you really talk about the linear programming, right? One is the proportionality. So if each variable is contributing to the objective function independently in proportion, right? If the whole, let us take, like you're getting the total profit that you really get, like 3,000, and there are, like 3 decision variables. each one of them are really contributing to the whole, like objective function and then to the whole profit. So, I mean, if there are dependencies between these, like the contributions, then the problem is going to be difficult to really solve, or it is not a linear. It is not under the assumptions of linearity or linear programming, right? So additivity is a similar thing. So basically, if you're consuming each of these resources, like to produce some of this, product, the resource that you are really using it, if you really sum up, it will really go to the, like the overall resource that we really have, the capability, the capacity that we really have. Similarly, divisibility, the solution that you really get it need not to be, like a full integer values. It is going to be a fractional values. And certainty is like where you are uncontrollable variables. For example, like how much labor is required to produce something. All these are, in certainty. If they are going to, it's not going to be a range. The exact value that is really going to be used. Yeah, obviously linearity, all the functions you are using the linear, and the non-negativity, all the decision variables should be positive. So these are all, like assumptions in the linear programming. So, I mean, any one of them, if you are really not following it, either the results that you might really get may not be, like right, or it may not be possible to solve the linear program as such. Okay, so the steps involved in this, you identify what are the decision variables, find out the constraints, find out the objective criteria, and then solve the problem. There are, like two methods that you can really use it to solve this, like optimization problem. One is a graphical solution. The graphical solution is definitely you can do it if there are only two variables, because anything more than, like two dimensions, like is going to visualize is going to be really difficult. And you can anyhow n number of constraints, but two variables. And you can always apply the different methods for the algebraic solution, like simplex, ellipsoid, and spheroid methods, like. But simplex method is, as I mentioned, is the one which is more popular and widely used. Okay, now let's get into a simple example here. I'll take, like a couple of minutes to really quickly walk through, like what is a graphical method. Then I think you will get an idea of like how it's going to really find the feasible reason and solve it. Then probably we'll jump into the other example. So this is you are trying to maximize the function 350 x1 plus 300 x2 with these constraints, such that the constraints that you have is what x1 plus x2 is less than 200. There are some of labor, some constraint. There's some example, right? And x1 and x2 is going to be greater than 0. So how are we going to solve this graphically? So if you take the like first constraints, trying to plot two variables x1 and x2. I mean, if you take x1 is 0, x2 is going to 200, and x2 is 0, x1 is is 200. So you draw a line between 200 and x1 to x2. And now with this one kind constraint, the blue area, whichever you're seeing, it becomes your feasible region. Now, I think you are going to draw similarly for all the like constraints that we really have. So this is the another constraint 9x1 plus 6x2 is somewhere is 175 to 260 some range. You will get another line. And then you take the another third constraint. There are three constraints in this here. So if you look at the another constraint, which is 12x1 plus 16x2 is so and so and so, you'll get another line. So now the feasible region is the shaded blue area. So your solution lies somewhere in this feasible, the optimal solution there in this feasible area, and which is satisfying all your constraints that we really have here. Okay, now just to look at all the extreme endpoints in this feasible area, there are what is the objective, like value that we really did. In this particular case, the value is 54,000 in one case, 64,000, 66,000, 60,000 and all. I mean, you can take any one of the extreme point as your solution, but I think this technique may not work if this solution is unbounded. We'll talk what is unbounded. Basically, this is now within the region, like it's enclosed boundary, but if it is somewhere not closed and then it's open, then it is an unbounded, like we don't know where exactly your optimal solution lies because this is not bounded solution. So this is one way of looking at it. Or what you can do is you can really put at this, like isoprofit line. What, if you look at 350 x1 and 300 x2, it translates to somewhere 100 and like 120 line, like the X1, X2 and X1. You draw a line and start moving this line upward and then see which is the topmost point that really touches. I mean, in this particular case, again, it will touch the like optimal solution, what we have really identified with the extreme areas. This is the optimal solution that we really touch. The same line is touching here at the optimal solution. Okay, so now there are so many things that might really go. It's not that all the problems will have a solution. So some of them will have alternate optimal solution. There is more than one solution might be possible with the same like optimal value. The value may not change. The same value. I mean, whether you take this route or you take the other route, you'll still incur the same cost. That's what it really means. So it means you have multiple solutions, redundant constraints. Some constraints may be outside the feasible region. Unbounded solutions. Basically, the solution region is not closed; it's open. And infeasibility, there is nothing which is going to satisfy all your constraints. And degeneracy, I think this is a type of problem where you say that one of your variables is going to be equals to 0. So probably it is. I mean, like may not be like good to discuss in this particular at this point of time with the available information. We can just leave it. Okay, so I mean, basically based on the insight that we really get it, how do we get into algebraic solution with a simplex method, and where you have more than like 2 variables that are really involved. Okay, let's get to another example, which is a real use case. I'll take this example. This is a like study of the BMTC, in Bangalore. IAC has done some study on this. Actually, in fact, this is a bigger problem not only in BMTC but across the urban regional transport offices, right? So, I mean, there are a lot of reasons for why they are not efficient. Many different reasons are there, but one of them is the bigger piece of contribution is this concept called dead kilometer. So, what is a dead kilometer? Each bus will go to the depot at the end of the day, and when in the morning it has to really start their service, they go all the way from the depot to the starting point, and from the starting point they go to ending point. They make many trips through the day, and after dropping the passengers at the end point, again they go back to the depot. So these 2 trips that they really make it from depot to the starting point and then ending point to the depot at the end of the day are 2 non-revenue generating routes, or like operating kilometers. Basically, you travel, but you are not generating any money out of those 2 travels. If you try to minimize this dead kilometer, obviously you are like reducing it, and like it's simply the problem is you have so many buses, so many depots are there. You have to figure it out, like which route bus to allocate to which depot, so that you are minimizing the distance that is traveled when you start of the day and also during the end of the day. There are some interesting statistics. Actually, in fact, there is a link somewhere here. I think, yeah, the BMTC performance indicators. They give you a lot of information in this each of the year. I mean, the dead kilometer is not an information that really comes as such. I think you have to go back and talk to them and then identify it, or maybe calculate based on it. But this information is not mentioned, but the remaining all other information there in their website also as such. So this is a little dated, 14, 15, but you have if you go to that, like website, you will find even the latest data. Look at it. I think, they tried. I mean, again, there are a lot of constraints. I think if we go to the realistic scenario, there are so many other constraints. I think probably it is not that all the buses can be assigned to, like any route. I mean, any bus can be assigned to any route. There are certain cases, like certain buses need to go to only certain routes. The constraints are also many are there. And also sometimes, based on the drivers, like preference and all of them, you may have to go and assign that bus to this particular depot. With even all these constraints and all of them, I think they try to optimize this problem and then reduce the cost from 63 crores to 56. I mean, this is actually projected. This one, it is not the real implementation, but obviously they given the details back to the BMTC, but we don't know what really happened afterwards. So So I'll go to now a simple example here is a product mix. Like I think I'll just take a simple example here, and we will walk through how to formulate the problem and also how do we really solve this using in the Python. So I have probably 5 more minutes. Let me see how much I can really do it. I mean, this is a furniture company which manufacture desks, chairs, and like bookcases, and there are constraints here. Maybe I'll just give you a couple of minutes for people to read and then tell me what do you think are like the decision variables and what are the constraints here and what is the objective function.
Anyone is free to unmute and maybe read through it and talk about it. You don't have to summarize at the end of it. So let's make it easier. What do you think sir, maybe you want to ask the questions.
Yeah, I mean, in the interest of time, probably I will. Yeah, sorry, go ahead.
No, I was going to ask like what the different constraints could be and break it down into different things.
Yeah, I mean, this is a very simple problem, right? I think.
Yeah.
Is someone speaking?
Please go ahead. I don't know if anyone else.
Yeah, it's okay, no problem. So desk, chairs, and bookcases are 3 products. I think the whole problem is to really solve what products I want to really, how many numbers I need to produce. The constraints are each of them will take certain, machine cutting hours, and I have a limited capacity. I have 100 machine cutting hours, and then each of them will take 0.8 hours, like desk, chairs, and take 0.8, 0.4, and 0.5. Similarly, once you really manufacture them, there is a polishing and painting activities are there. It needs some manpower, and then there are 650 hours are available. And again, what is that? Like each one of them will really take it. Similarly, once I really manufacture all the products, I have a storage capacity which is 140 square meters of capacity, and how much each one of them is really going to take. There are 3 constraints here. One is machine cutting, machine hours, manpower, and the storage constraint. These are the 3 constraints. And if you sell this product, I think directly they have given the profit here, 30 rupees, 16 rupees, 25 rupees for each one of the products. So obviously, I mean, we have to maximize the product here. That's what is the problem. So the way that we really formulate before go to the Python is like, decision variables, number of desks to be produced, number of chairs to be produced, number of, okay, I think I made a mistake. All of them are. Okay, number of bookcases to be produced. Constraints is machine cutting capacity constraint, man-hour capacity constraint. Whereas the way that you represent is, like 0.8 into number of desks that you are producing in 0.4 into number of all those things. Just, I mean, you have only capacity is 100, so it has to be either less than or equals to this piece of it. Similarly, the man hours and then the other one, right? So the objective function is going to be maximize the profit, which is the profit that you get by from the desks into 30 plus the number of chairs into 16 plus 25. Okay, so if I want to translate this into the Python, before I go to the this one, but let me explain how and the way there are a lot of different ecosystem that we have here, right? So many of the packages that we really get are the modeling or modelers or modeling packages. Basically, they are not the solvers. So you use any one of them, Pulp, CVX, PY, CVX Soft, or PyMo, and all of them. You use this package to model your problem. After modeling the problem, you can give it to any solver. I mean, I've given all the solvers here, but there are many more solvers are there. And whichever is highlighted in the dark are the commercial solvers. And whereas the ones which are, below are the open source one. Once you give it to the solver, see now you look at it. I'm framing this or modeling this problem once, but I can give it to any solver. Whichever I don't have to change. Tomorrow, if I change my solver for whatever reason from open source to commercial or commercial to open source, I don't have to change my formulation. The formulation remains the same. The solver is the one which you really not go and give it. And otherwise, some of the cases where you can export that, like in the MPS format. MPS is very widely recognized format across the different solvers, and you can give that back into the solver to solve the problem. So this is the way that you have the whole ecosystem is there. I can quickly go through what is the there. I mean, this is the same problem that we really mentioned, but I used pulp here. The pulp is I use it for like few other solving the problems. I think it's easy and also it's really good. So first thing is define the problem, and you are telling it's a maximization, right? LP maximize. That's what we are giving a variable. You are giving a name to the problem and say this is the problem. If you look at the problem now, it's just nothing. It's just a maximize problem. Nothing is there at this point of time. Now you create your decision variable. There are 3 products are there. I'm creating a variable, and I'm giving the name as well as I'm telling what is the low bound. Low bound means basically, like some of the constraints for each of the decision variable. It needs to be within that some low and upper bounds. That's what it means. But low bound, we are telling 0 so that it should be greater than 0. We create these decision variables now, and then there are different constraints. I mean, if you understand one of them, then similarly we apply for all of them, right? The cutting hours for each of the product is this. What we're really trying to say is we create an expression here. And this expression is, I mean, the way that you really look at it is once you create a blank expression and you keep on adding anything to expressions. So it's like any number of individual expressions you can add to this expression, right? So the expression here is what is the resource required for this particular operation into the how much you are really going to produce. That is the decision variable here. The previously created decision variables in the above here. I'm taking the decision variable for that particular product and multiplying with the resource requirement. So I'll keep on add them for each of the operation, like cutting operation, like all of them, and then you create a constraint. The constraint here is the cutting hours constraint. So you use the LP constraint formulation to create the constraint. Again, the name, expression, and the name of it. It says that the same thing. It also represents the constraint. If you look at it, it represents in the fashion that I really put in the like my verbal formulation earlier. 100 is, I mean, the way that it writes is actually, in fact, always the right hand side is equals to 0, so that it will bring the number back into that equation. Actually, the way that the package treats and all those variables like that. And just add this constraint to the problem. You're adding this constraint to the problem. Similarly, you have another constraint, man-hour capacity constraint and warehouse capacity constraints. You put all of them. Now, if you look at the problem now, the problem has been formulated here now. See, the maximization problem subject to these 3 or 4 constraints. And these are the variables, and variables can be continuous or it can be integer also. So finally, I add my objective function. Objective function also is an expression without a right-hand side. And it will know when you add a expression without like a right-hand side, it knows that this is an objective function, and then automatically it will treat that as an objective function. Here, the same, the decision variables are multiplied each one of them. Okay, so once you really take and solve, this is the solve problem, and these are the recommendations. Like I think the optimal solution, desks, chairs, and then bookcases, whatever is there, right? I think these are the ones. And then, if you look at here, the constraints, all of them are 0. It means that the whole resource is being consumed. There is no resource left out with the optimal solution. If at all, if there is any resource that is not consumed, you will see that in the when you really print the constraint values here. Actually, as I mentioned, there are, sorry. Okay, probably I'm just going to conclude in a couple of more minutes. Hopefully that's fine, right? Hello?
Yes, of course, please.
Yeah. So there are the different solvers are there here. Like I think the pulp is, if you really want, I think you have to just go and configure. The configure is, when you run this, actually, in fact, it is running another external solver. The solver has to be installed in your system. It's a command line parameter. That's the reason if you see a lot of them are Cplex CMD, Cplex DLL, based on the operating system or based on, like where you're installing it. You have to configure these things. And once you configure these things, you can really give that as a solver when you're solving it. So in this particular case, I have only 2 solvers available in my system. One is SciPy and then, GLPK. Okay, so the last one, actually, the way that I really put it is, like I think if your problem is more complex, there are so many variables, so many constraints, writing all of them in the programming is going to be little difficult. So there is a AMPL is there, like a mathematical programming language. Actually, this is the standard. I think there is a PyCache called AMPLY. I think AMPLY. This will help you to put the data in such a fashion that you don't have to really create all the variables, right? So, excuse me, in this particular, the same problem, all the data I'm putting into a string here. It's just a string here. There are two major things are here. One is a set, another one is a parameter. Set is nothing but a, like a values, like a set of values. So I'm calling products here, desks, chairs, and bookcases. Operations, there are three operations: cutting, finishing, and storing. And this, like sets can be multi-dimensional. What I'm really trying to create here is I'm trying to create what operations are valid for what kind of product here. So I'm telling product operations as a dimension, 2-dimension, this one. And I'm putting product operations as desks, chairs, and bookcases, and cutting, finishing, and storing. And I'm putting plus or minus here. Minus means that is not applicable. Plus means it's applicable. So, and all the data, whatever that I've really put in the constraints, I've put the operation requirements for each valid product operation, like cutting and desk, what is the resource required, right? Similarly, what is my capacity here? Capacity available by operations. So the parameter is nothing but a dictionary. For this particular dictionary, for the values which are there in the product operations, what are the different values that we are defining here? I think we have, I'm defining three: operation requirements, capacity available for all these things, and then the profit. What is the profit, for each of the products? So once you really have this string defined, simply read that, pass that string to the library, you will get all your, data. So data.products, if you look at it here, this is the desk, chairs, and bookcases. So you don't have to really go back and define them. I think this is going to be much useful for people. You want to define complex data, like complex data, you don't have to write the programming to really structures to really define that. It automatically read from this, and you can also name them properly based on the problem that you're really solving. And the remaining is same. Once you have this, I'm just creating the same decision variables, but this time I'm using this data object rather than the objects I've created in Python earlier. Same objective function, and then constraints also, I just loop through and then create everything. This looks neat and clean and then easy to really do it. I think the remaining all is going to be same. So, in conclusion, the business analytics area, if you really, there are a lot of areas, a lot of, like insights that you can really get from the data, but it is associated with a lot of other operations, like you extract the data, like aggregate the data, like you might have to build the systems to really have these things. But once this is available, the operation techniques like linear programming, mixed integer linear programming, simulation techniques can help you to in the prescriptive analytics. So where you have a business decision to really make, and you have, like set of limited resources, and then you want to come up with an optimum, like for a maximization or a minimization problem. Based on this limited, resources, you can do that. So, and Pulp, CVXOpt, and CVXPy are the packages that can be used in Python to solve these problems. I've given very small problem, but there are very complex problems that are there that you can really formulate and solve it. So, and particularly Python helps in a lot in the debugging of these problems. Even if you make a mistake here and there, it's very difficult, very easy to really debug. But whereas with other programs, it's going to be very difficult. So these are the two files that I've really exported at the end of it. You can really export into different formats. One is LP and then NPS. And I have, so yeah, this is like another Lingo is another, like software academic license. I'm using it as part of my course. You can, just import that particular file or into this one. Okay. I don't know why it always gives us a minimization problem. So this is the solution for the same problem here in this particular package. So, interfacing with any package is going to be easy because you have the standard MPS format to interchange between the solvers. I'll stop here and see if you have any questions. I think I'm already 10 minutes more than my allotted time. Sorry for that. So
No problem, sir. That was a beautiful talk. Do we have any questions for Sushil, sir? If you
Yeah,
have questions
hi.
that you, okay, carry on.
Hi, Sasi. So, like, there is one question like, whatever we wanted to optimize there for this particular problem, there if we put some constant, like minimum, we want to sell 10 chairs, I mean, or this type of things, then like, where we would have done the changes, I mean, what changes needs to be done there?
okay, so what you're really trying to say is the other way of putting it is, for example, I can produce, like chairs, like now we have not given any constraint here. I can produce any number of chairs or, desks and all based on the capacity that we have put it. But another one constraint you can add is a demand, basically. Yes. So what we're really trying to say is, in the market, I don't have any demand for bookcases, like I just only have, probably if I sell the whole month or, like I only have 10 demand, you can go back and say X bookcases is less than or equals to 10. That is the constraint you write it.
Okay, okay. Can you show me the solution once, this whatever the solver is giving here?
Yeah, this is the solve, and then this is the 100 disks, 37.5, or maybe you can even put prop dot to date. Sorry.
Yeah, I got it.
It give you all the like variables, constants, and all of them dictionary format also. If you want to have it. Yeah.
Okay. Yeah. Thanks.
Yeah.
If you have more questions, and you can also put it on chat. So yes, sir, do you have any links that they can probably reach out to you afterwards, if you want to?
Yeah, I mean, I am not very. This one I can share my email. People can want to send me an email.
Sure. Meanwhile, let me just reshare our feedback link. This will help us in organizing a better event next time. So please take some time. It's not very long form. It won't take much of everybody's time to do that. And yeah, thank you so much, Vijay sir. That was a very good talk. We can move on to an open house session. Ritesh, Abhiram, if you are there.
Yep.
Hey.
So also to everybody else. Yeah, sorry, Abhiram, you were going.
No, please complete your thought. No problem.
So if somebody wants to discuss something, have very specific topic in mind for open discussion, feel free to put it up on the chat. Abhiram, can you?
Yeah.
I will stop and share. Yeah.
Sure, sir. Ravi, thank you for the question. That was something that I think would have been in many people's mind as well. Like, what is the other side of the supply thing, right? Like, everyone thinks about what is the most we can spend, but what about the minimum that we have to make, right? So that is also a very important problem in supply demand problem. Like, for full disclosure, I am in a supply chain company, and this is like very important to us as well. So the talk was really good, sir. In terms of open house sessions, right, we normally don't have a very clear agenda because we've tried with having agendas and somehow it always falls flat. So I think we will just we've always ended up having organic conversations, and that have been good. So now I think we'll do the same thing. Regarding the 3 talks that we've had so far, what sort of pointers do you think you can give us? Like, anyone can speak about what you would have liked to see more right? Like in terms of concurrency, is there something that you would have? I mean, this is part of the feedback form, but I think when we have people, we might as well make use of it. We have the speakers also. So is there something that you found missing in the concurrency talk that you would like to complement your knowledge with? It doesn't have to be a specific answer to this question. You can also completely go off a tangent.
Also, I think Anshul had a lot of content and not enough time. So there was a lot of discussion happening around it.
Yeah, I think the topic itself is like too many things are there in the topic to discuss, so including async IO. I think that's good. That's true. I think the time was probably less for him to cover more.
Yeah, it was a really great session. So like in the previous company also, like I had to like parallelize the code. Like it was, the problem statement was something like if we have something around 20,000 products and if we want to get the optimal discount basically for those things, something like that, or we have 5,000, then it was taking huge lot of time. So I had to optimize that thing, basically the response time. So like I was using one package in the Python. There is one package, it is threadpool, I think. Yeah. And then like I used the both, basically the multi-processing and the multi-threading both, and randomly just I selected like multi-processing was quite faster. So but the thing is behind the one, like what is going on, I got able to thoroughly go into that. But Anshul really, in a well manner, means he explained. Yeah. So when we should go for which, yeah. But which would be better? That thing I want to know. So there are some packages in Python. I don't remember exactly name which one I implemented. Threadpool executor something, and we can implement even without using that package also. The way like Anshul was showing. So that thing I want to know, which is better basically. Is there something which will make some more impact without using predefined package?
See, ultimately, it comes down to the number of, I'll give you my perception, okay? Everyone has their own, and I'll tell you the objective version first. Everything is governed by the number of cores that you have, okay?
Yeah.
That is the base thing. So in terms of, if you're able to write it from the ground up so that you can use the cores yourself, it doesn't really matter what packages you use, because ultimately all the packages are providing a little bit of an API interface. API to help you leverage those cores a bit better. Okay. In terms of machine learning also, if you're concerned about machine learning, there you are again bottlenecked by the sort of parallelization that the algorithms themselves have. Like if you have something like n jobs as parameters in some of the ML algorithms, right? So those are your bottlenecks in terms of like how parallel can they do stuff. And when you come to non-ML jobs, like the sort of use case that you said, you are okay to go with a package because of convenience. You don't want to bulk up the code writing your own functions. Why? Right? Like you already have something that is out of the box. That is where the convenience comes in. Okay, and that's what I would say. Like if you're okay to write stuff on your own, you should. If not, use the package.
Got it. Yeah. Thanks.
So particularly the another area is like at least I have seen when you're deploying your maybe machine learning models as well as some of the resource like intensive things, and you're creating an API. The architectural patterns that are available to work with this kind of threading, multiprocess and all of them with the web servers coupled, right? I think like something like with Flask, how do you orchestrate the whole thing? Let us assume that you're taking a document and it's a PDF document and there are a lot of images in the document and you want to use OCR techniques to scan through. The user experience is that user submits the document, asynchronously should process it and notify the user when it really completes it back. But there may be multiple users, submitting the, multiple documents through the web server. So probably, I have seen there are different practices people follow. if someone has really worked on that area and then to bring, like what are the good and bad things about it, how do we really work with these kind of things when particularly in the API development or maybe web development, this would be, or can even somebody has experience can talk also, I think.
Conveniently, I have seen Python is not a great language for doing concurrent requests. But if we have to, then threadful executor is a good way.
See, I think you are absolutely right. But problem is like, at least I should have, like, because majority of the libraries available, good libraries available in Python, particularly PDF parsing or maybe
Right.
doing other things and all of them, and even machine learning for that matter. So getting completely away from Python and doing in a different language, definitely that's if there is a possibility, that's an option. But in case you have to, then what is a good practices, or what patterns are there which will really, architectural patterns will really work, might be helpful. I mean, anybody who has really worked on it, I'm just asking for their thoughts if they have done something.
So like while creating the API, we can always use the async await, right? So like if there are n number of users, then it will not block to each other. That is what you are trying to say.
Yeah, async await along with like Flask or some. I mean, it's not separate process, right?
With the Django, I have used async await. Yeah, so it works basically with that.
It really depends, right, on the use case to use case basis. If exposing concurrent requests to multiple users, they are trying to hold the same resource from the database or the same data, then it might pose a problem from your DB side. Again, if it is possible, then absolutely we can scale it up like that. So it really goes from case to case basis. That's what I feel.
Yeah, multiple users, if they will use the same resource, the same value you are saying.
One point here. So when you call up, when multiple people are accessing an API, you're ultimately making calls to the database, right? That is the base problem where multiple requests are going to the database. So it's really a question of which database supports better concurrency, right? So I think most mature databases now are capable of handling that. So isn't that, I mean, Django also supports it. So what is the...
No, it is not. Sorry, I mean, probably, yeah. I think one is database, but the other use case which I was mentioning is the resource intensive on the server, which is going to be like a OCR technique, right? If you really go back, if you try to read a scanned file, from any of the Python libraries, it uses multi-code. Obviously, the libraries will automatically use the multi-code. There's no problem. But what happens is you should be able to handle this kind of requests, multiple of them, coming from different people. But again, as Aniruddha mentioned, there is no single solution for this one. It depends on each one of them. But I was trying to think if anybody has really implemented such kind of problems, or like if they have experience or they have faced problems, or what kind of solution patterns they have really used it. So that is what there is no specific problem to solve here, but if somebody has worked on it and then they have any patterns that they can really say, that would be helpful. That's all.
Yeah, as far as OCR goes, I have done it only once, and it was at a hackathon. So we really didn't have many concurrent requests. We had one, and we were just like stuck at getting that implemented properly. Not stuck, like we were focusing on that. So should probably look into it a little bit more.
Guys, you hear me?
Sorry, go on.
Oh yeah, I'm sorry. Like I was just checking. Aniruddha, around something that you mentioned, Python being not so good choice when it comes to having tasks being put into concurrency, right? What would be your go-to like language solution or technology for those kind of things?
So I mean, if we have to use Python, I have felt Fast API has been really helpful. Recently I tried building some services on Fast API, and they scale up really well on GKE or the other Kubernetes clusters around things. Also, I've been trying on Golang, and that has actually really helped. In like from the latency side of things, we can clearly see a very good performance jump. But
right.
yeah, I mean, it depends again from case to case basis.
Got it.
Yeah. So
Sorry, I just want to continue the question which Anirudh said Fast API is a good choice. So why is Fast API a good choice? Is it because they are using async awaits there?
Yeah. That and they have a very low this thing, right? So they don't store this the request on memory, and they will just process it on thread by thread basis itself. So it doesn't hold resources for a very long time. Um, I mean, we can go on probably in depth around the Fast API thing. So Fast API was built on top of this thing, what's it called, Flask, right? On the same concept of Flask, basically, and that goes from a very low resource standpoint perspective, as compared to something like Django, which is good for larger applications, but not so good if you want to have concurrent requests flowing.
yeah, for the like microservice architecture, like Fast
Yeah,
API,
exactly.
really fine. Like, so I have been using Django for quite some time now. So like, if we want to build fast whole application, like I would still go for Django because it has all of its pieces still stitched. But if we want more towards the scalability side and have the lower memory footprint and bottleneck, I would say. So like I won't say it is a bottleneck, but like you want some customizability and other things because it has its own ORM and all those things. So if we want some more customizability and lower resource, as Anirudh mentioned, that lower resource uses, then we should go for like Fast API. We can go for basically.
Yeah. I mean, since the time I have used, I've become a fan of this of this framework. So maybe I'm a little biased also. I don't.
Yeah, and also it has type hinting and like Swagger automatically with it, right? Some cool.
Yeah. I mean, yeah. That is again a different question. A lot of people might not like the open API spec way or something. So maybe not for them. But
Fast
overall,
API is specifically for this use case, right? For APIs and RESTful services and stuff, right? Unlike Django that supports the whole array of whatever web development has to offer.
correct.
Am I right?
This is very microservice specific thing.
Yeah.
This is modeled for high performance, basically. So it has to be very small.
We've also been hearing very good things about the Falcon framework. Has anyone worked with that, and does anyone have any thoughts on that versus Fast API?
Not really. Would you like to tell us more about Falcon framework?
Yeah, I mean, I think the core philosophy was again keep it blazing fast, and it's for like very minimal REST APIs which don't have a lot of fluff associated with it. And what they do is they try to replicate the HTTP interface, right? So everything is built keeping the whole HTTP spec in mind. So when you define your routes and everything, you say, okay, on get you do this, and it's basically trying to mimic exactly how the HTTP is built, and it's supposed to be blazing fast. But I don't know about its concurrency and things like that, so I just wanted to get some thoughts if anybody had them on Falcon. But yeah.
I haven't tried it yet. If somebody has, feel free to come up. I think this is the link. Oh, sorry, Prashant,
Yeah.
go on.
I actually worked with the code base of Falcon as well as explored Fast API for a bit. For me, the Falcon felt more like opinionated, and a way of doing things. And it's clean as such. You have resources, classes for object-oriented way of describing the entire REST APIs. And it's nice if you have adopted it. But otherwise, it's a lot of constraint to, like, if you want to put together something like really quickly, Fast API or even Flask is very lucrative because you have control over routes, and it's kind of like in the mix of Django and in between Django and Flask. And apart when it comes to performance, I think it can do both, as in how you deploy it with G-Event or G-Unicorn, and it has multiple runtime supported as well, right? So I guess it comes down to how there is also importance to how you deploy the application.
Right. Yeah.
Got it.
I mean, yeah, the choice of architecture is also a question of a question to go with. So, from I think from a pet project perspective, we would like to have the choice of architecture on ourselves. But when we go on to build like an enterprise grade application, we would want to have something which has an industry standards on terms of architecture, because then there'll be less knowledge transfer for the new people who are joining in. I mean, that's what I have felt.
Understood. Got it.
So sometime back, I checked on this particular site. So it was having like a benchmark of many framework on different use cases. So although it is, I think, kind of very detailed, but yeah, it gives some idea like which framework for which use case would be better for you, and how we could choose a framework based on the use case. So it has like, I think, around 300
There's 436 frameworks there.
So
I mean, sorry, go ahead.
Yeah, go ahead.
No, I was thinking, another question that I was thinking is, like, there are so many frameworks here. What are the typical parameters one will consider? I know this is only the performance wise, right? I think as Aniruddha was mentioning, it is like enterprise and all of them, and you want to build a product to something like that, then you want something like a production grade kind of thing. What parameters do we really consider to really say this is a production grade? I mean, there are so many frameworks coming up nowadays, at least we are better than the JavaScript world, but still there are many frameworks. How do we say which is the right one to really for my production grade application?
I think I should be asking you, sir, this question.
Unfortunately, we have like our own team in the enterprise. Like what we have to submit any open source working to the team. They look at not their first priority is not the like performance other thing. The security is a very first requirement. If it meets the security requirements, then they really ask you to do anything afterwards. So I mean, as long as
security and legal.
Sorry?
Security and legal.
Yeah, licensing. Basically, security means like one is license wise, there are no loopholes, and then second thing is, I mean, it's been maintained. Like all those kind of things. They really look at it, and then there are no.
I think dependencies are a major factor for security as well. The lesser the dependencies, then the more auditable it can be.
Absolutely.
And most of the time, like this very process wherein they'll have to look into all this is gonna introduce the lag in what's happening in the market and what our organizations are using, right? Because like most of the times we'll be using something that's already mature, not something that would have entered the market like really like in the I mean something that's latest.
Yeah,
That's something that I have noticed. Yeah.
Nobody wants to take the risk with their own product.
Yeah.
But that's the beauty of having a lot of pet projects, that you keep experimenting with the new stuff that comes in.
And I would say, I think kind of microservice architecture has allow us to take a little bit of a risk, because you need not to change the whole application at one go. Like you can experiment with less critical components and try to be more like those components could be more, I would say, cutting edge technology. Although it depends, like Yeah, so those kind of things we could experiment with, but yes, although in the production we also tend to not do experimentation, as like others were mentioning that we should not do experimentation, but I think this service architecture has helped in making those components changeable.
How many of you guys are still working in your own on-prem? Or maybe I know a lot of people or organizations, including some of the financial services companies, are moving to cloud. I mean, are there any organizations still they work, on their own infrastructure, and then is there any reason why they want to do so?
Yeah, basically whoever uses financial related projects, so yeah, they are using. Even my current company, they have basically, yeah, I mean, all the NBFCs and banking client, so they are using on-premise cloud. They don't go for public.
So in yeah, go ahead, Ravi.
Yeah, even in our company that I'm associated with, we have on-prem things. It's mostly around security that we are worried about. Like, so it's a fintech company, so that and like being able to work alongside the mainframes there. That is one of the reasons why it's still on-prem.
In our case, like my organization is like on the cybersecurity basis, so we ourselves don't have on-prem, but like majority of the our clients are on-premise. So like we have seen in the global ecosystem, I think India and Middle East are still like towards more on the on-prem, but USA and others are moving towards like cloud. Like they are okay pushing the software on Azure, AWS, although they will have their own policies of dedicated system and all. But yeah, in our case, like in India, mostly the financial sector is mostly on premise. They still bit reluctant for cloud.
What does it do at Fidelity? I wonder.
Fidelity.
Yeah.
I mean, we actually had a lot of data centers in multiple places, multi-billion-dollar data centers, and then now we are moving to cloud, all of them, but not one cloud, multiple clouds. Like one is Azure, another one is AWS, AWS and Azure, both of them.
Oh,
I mean,
nice.
that is why I'm just wondering, like my company was very conservative. We don't want to get into, cloud. I mean, even I think around 8 years back in one of the, like in this one, the discussion, people were saying no way that, we can move to cloud because of security. So
yeah, I mean, even when I was trying to convince people to actually go towards building decentralized products, and they had their own servers and stuff, they were like, even if you want to deploy a decentralized product, you'll have to deploy it in our servers, and it will only operate inside this network. I mean, there was ultimately no point on that. So yeah, I've also seen a lot of companies in India very particular about where the entire thing is being stored and being operated from.
Yeah, it could be. I think I would say related to control or control in their hand, like because
exactly.
most of the customer choose their own DCDR, like data centers in which region they want to put in. Otherwise, like in India, if we say that for AWS, it's one Mumbai region is there, but you cannot choose any other region. But for I think critical sectors, they need to choose their own data center places as well.
No, that's also fine. No, like even if they choose like say AWS Mumbai region or DigitalOcean Bangalore region, that's also still okay. But these people will have physical servers set up by themselves, where things get very, very complicated. Like we can't even deploy from outside. We'll have to go there and deploy it on there directly.
Correct. So in our case, like we have to like given a security product, so we have to allow whitelisting and like at least it takes 15-20 days just for allowing our code to be downloaded in the on-premise, and then further processing starts. So all those security things comes up, like firewall and yeah.
Interesting.
So
Yeah.
these were the inertia that was associated to the move towards cloud, right? But those companies that have actually started moving, what are the benefits that they are seeing compared to the previous world? Like understood, Shashidhar sir mentioned that Fidelity is now trying to go into the cloud region. So what are the benefits that it is seeing now?
I mean, one is definitely this elasticity, right? I think what happens is if you really build a data center, once you procure all your, like everything, you have to use it. There is no way that you can really say, I'm going to scale down my operation. So, but where here, I think you can go on, any point, because for certain time, probably, like you have a peak load and then afterwards you have less load. You can scale down your operations very, very well. That is a bigger advantage. But obviously, I don't say cost. Cost is not, less with respect to that, with the cloud versus on-prem, because it's all depends on how you educate your people, how you architecture applications, and how use your resources. So cost may not be a very big advantage, but elasticity is a very big advantage, because I can really spin up something and I can really scale it down and all of this stuff. So it's all possible.
Oh, yeah, makes sense. Cool.
I think one of the things is also about hardware and how you have like flexibility with like awaiting latest upgrades to the hardware without having to, upgrade the entire data center yourself. That's where cloud can really seem very lucrative. And the way the speed of things are changing, like how fast the processes are becoming, you can really make use of that. Is like really nice.
Yeah, I think that is definitely true. Yeah, right. I mean, some of this, if you're working on, like AML projects, you need GPU instance only for certain point of time. You don't need it forever, right? So you can, those kind of instances, if you want to build your own, it's definitely going to be much expensive and difficult to maintain. Those kind of use cases, very good use cases. Yeah, you're right.
Absolutely.
Had this one thought around whatever Rakshit presented. Is Rakshit around? Yeah. Like with federated learning, right? All the compute of all the clients that are connected to your server is also a factor in how the working goes, right? Has there been any research around that? Like the different the different capability of your clients, did it have any impact on whatever was happening on the servers and all? Is Rakshit around?
Rakshit, you are muted if you are speaking. Probably not around.
Okay, cool.
So yeah, I think we are discussing these things, and anyone has any views, feel free to jump in. Like otherwise, like we are having the conversation. Anyone wants to have put their views, how they are doing the on-premise or the framework thing, or our scalability thing. So yeah, anyone has any view, please feel free to jump in.
Sorry, this is just not related, but is there any plan of meeting physically in the near future or not really?
Oh no, not anytime soon, because we've been seeing like these constant spikes, right? It can't even be called spikes. There's constant increase. So in the interest of like mass safety, I think we'll stay away from the physical meetups for a while. And it's also about hosts, right? Like companies are not still wary about giving us places to be in. I've checked with a couple of them to see when they'll be open. They're not even open for their own employees, let alone meetups, right? So I think Zoom is going to be our vehicle for next at least 3-4 months.
We can wait and see how things spiral out. If things get stable soon, which is very unlikely as it
Very
seems right
unlikely.
now.
Yeah, earlier we were thinking on like April, May, like when we were thinking, yeah, cases are all stabilizing. So earlier we were thinking on the same, but now again we have to follow the weight and all the strategy.
Yeah, I mean, like, just when I was getting a little bit hopeful, I mean, things started slipping out of hand. So now I'm being cautiously pessimistic.
Got it. Thanks.
I think we can conclude for today.
I just have one more question. Wait 1 second.
Okay, sure.
How many of you are not from Bangalore, as in like not in Bangalore right now? Because that makes a case for online meetups even more. if
I'm not in Bangalore.
Huh?
I'm not in Bangalore.
Great. See, we have at least one person who joined because it was online.
I'm
There are
also
two
not in
guys.
Bangalore.
Yeah.
Nice.
I'm also not in Bangalore. From Kochi.
Who's
Ritesh
it?
also is not in
Priya.
Bangalore, is it?
No.
Oh yeah, Ritesh is not in Bangalore, man. Ritesh, Ravi. Jeez, I missed the race hands. Nice. So at least like 10%, 25% of us here are not in Bangalore.
Yeah, actually, I'm seeing even people have changed their even international conferences. They're now doing
Online.
a
Yeah.
common time zone for India and US kind of thing, so that people can attend from multiple places.
Seriously,
Yeah.
I've attended a few Pi Ireland meetups, Pi Amsterdam meetups, one New York meetup, and I couldn't have attended any of these.
Oh man.
Yeah,
Awesome.
it's a lot of fun.
On that note, PyCon India 2021 is also online.
Oh yes. Ani, have you already mentioned it?
Yep. We have shared the CFP. So yeah, I mean, if you want to submit a talk, CFPs are open.
Yes. Also, we have a joint meetup from all different the Python chapters in the country coming up on May 2nd. It's called Pi Flames, and we'll be sending out a note soon from our different chapter mails. But I think 15 of us are here, 13 now. So it's going to happen on May 2nd, and it'll be fun for everyone. I think we'll put out notes for like when it is and what time it is and all.
What is it? Pi Flames, sorry?
Pi Flames. Yeah, it happened last year as well. It's going to happen this year as well.
I want to. Sorry, go on.
No. I was prompting you to.
Okay, I wanted to ask something else. How many of you are comfortable with this morning time, or would you like our event to be have also around evening or afternoon?
I am definitely for this time, because I have 1:30 afterwards. I have a different thing to really do. So
I see.
I vote for this one.
Okay. Anybody else
I'm
have
also,
more?
I'm comfortable.
You're comfortable with this? Okay.
I'm comfortable too.
Hey, don't keep it afternoon, man. Actually, now itself, we don't know what is really happening behind the scenes. If you put in the afternoon, we don't know how many are sleeping and how many are really listening. So
Exactly.
No, I mean, I think we have experimented sometimes in afternoon. We had a few in the evening also. So we're just wondering if we should try out different times.
If I am allowed to vote, and I will. I prefer the morning. I'm already sleepy now, so after like digesting all this knowledge, I'm going to like sleep off. Right. So I think it's better for me in the morning.
And it doesn't
same
feel
here.
It doesn't feel that the weekend is gone.
Yeah, it's not yet, right? Yeah, we still have
Also that, yeah.
Perfect. So then we are
guys,
going with morning.
Just 1 second. I have a question about the job board. So what is the idea behind that? Like is it having a lot of traffic? Like who is checking it out, and is there a mailing list or something?
Yeah, Ritesh, Abhiram, you wanna?
Yeah. So about this job posting, let me give you a little bit background. Okay. So three of us, at least three of us before now, Rahul also, we keep getting a lot of these questions about, are there any candidates that are available for this particular role? We are hiring for another CTO that we want, or another co-founder. All of these questions keep coming up on an ad hoc basis. Okay. But for us to be able to post it on the mailing list, from time to time is a bit like, yeah, that would be a bit hectic, and also it comes so ad hoc that it's not formalized. Okay, so we have to keep following up on different requests before we can actually have it in one place. That's why this form has been put in place, and anyone who is hiring can fill it up so that we'll know everything in one shot. And we also have plans to put it out in our weekly or fortnightly newsletter. Okay,
Okay.
so that is where that is where it will be it is intended to go, so that it will at least be, for starters, it will be in the direction of for employers, and then at some point we'll probably also have like a lookup place for potential employees, like candidates.
Okay, got it.
That is the intention. So if you are hiring, if your company is hiring, please feel free to fill in the form and give us more inputs about more blanks in the form that you can think of.
Sure. Yeah.
Cool.
Has anyone worked for Turing?
The company, we see a lot of ads. I mean, like, I see a lot of ads for the Turing job. Can't think of any. That's what you're talking about, right? The mails that come in about Turing.
No, actually, I saw some of the ads. Then after I applied, I just had sent the resume and all. They had taken some test. I mean, it was objective only, Python, Django, and some data engineering stuff.
Wait, do you mean via Turing or for Turing directly? Because it is also like it gives people, it connects people to people,
Yeah.
right?
Yeah, it will connect with some different company. Yeah.
Right. So are you saying you
Yes.
applied at Turing or on Turing?
On Turing, I can say.
Okay. Via Turing, like
Via
Nokia.
Turing. Yeah.
Okay, then that answer is no, man. I don't know anything. But anyone else? I guess not. Okay, I mean, like, you can put it up on Twitter. Our handle is __ Bangpypers, and we'll retweet it so you can get more answers, or you can send it to our mailing list also. Okay. So yeah, all of these relevant opinions are welcome. Questions?
I think probably after some time, anyhow, it looks like we are dropping. I think now.
Yeah.
So I wanted to ask, anybody is involved in the study groups here? I think you are part of study groups, or you are done earlier and all of them. And
yeah, I was part of a linear algebra study group from this MIT prof Gilbert Strang. So that was very helpful. Like, we would connect once in a week, and we would discuss his lectures, and so we had a Slack channel, and we would talk about that. And during the week, if we had any questions about the problems, that is how we had structured it. It was very organic, but it became a bit more structured over time. So I have some experience there.
So it means that you only discuss or ask questions during that meetup, or you watch something and then together? Or
no, we didn't watch anything together. We watched it on our own time, because we all have different schedules, and we would discuss what we learned during those meetups.
Oh, okay.
And there is also this thing I was involved with called Code Buddies. That is open source venture. Okay, like, it was created by someone called Linda Peng, by Code Buddies, and I was contributing to that project. They had a lot of these study groups for discussing different chapters of tech, like JavaScript chapters from ESL, not ESL, that is statistical learning, from ES, I think, TypeScript. So all of that used to be discussed, different chapters used to be discussed during those study groups. So it is pretty popular on the net. So if you want to, like, if you have any ideas, we could start something and see who else would be interested in discussing the topic that you're interested in.
Yeah, I mean, at least I see there are a lot of, like, you're doing some projects and all. I think you have, either you can contribute or you can also learn from others on mostly experiential things on certain areas might be useful. But let us think.
Sure. Cool. I think this has been a fairly productive meetup. And again, thank you all for staying back. And I hope it's been helpful. We will put up the resources on the GitHub repo as always. Feel free to reach out on Twitter. We are on, again, you've already put the handle there. And I think some of you are already following me on Twitter, but I'll put up the IDs of myself, Anirudh, and Rahul. Ritesh is not very active on Twitter. So I'll put it up and you can reach out to us. 1 second. So this is us on Twitter. Rahul Kumaresan is... Oh, Rahul Kumaresan is Rahul Kumaresan. Okay. Very easy to... So these are our IDs. So you can reach out to us or on the Bangpypers ID above, and we'll get back or we'll help you solve your problem. Thank you. I'll be ending the call now.
Thank you.
Thank you. Bye-bye.
Again, yes, sir. Sasi sir, thank you so much for the talk, and to the other two speakers as well.
Yeah.
They're not here.
Good. Thank you. Bye.
Thank you.